So this is half past paper, week 8, non-calculator again this week. So we did non-calculator, all the odd numbers last week, and this week we're doing all the even numbers. 40 marks on this one. And as usual, all of the topics and all of the Sparks codes. If you do have access to Sparks Maths, then those are the codes of these topics, just so you can go away and practice them more if you think you might need a little bit more practice on any of those questions. Okay, question number 2. Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar, 2 times as much butter. Dion's going to make 60 biscuits. How much flour does she need? So we've got the recipe here, 15 biscuits. And I know that that needs 50 grams of sugar. We need 3 times as much flour as sugar. So I'm going to take that and multiply it by 3 to find out how much flour we need. And that is 150 grams of flour, and it says 2 times as much butter as sugar. So I'm doubling the amount of sugar to get the amount of butter, and that is 100 grams of butter. Great, so that's my recipe for 15 biscuits, but I don't want 15 biscuits, I want 60 biscuits. So how many times am I going to scale up that recipe? For 60 biscuits, we would do 60 divided by 15. How many times am I going to need to multiply this recipe to get 60? That is going to be 4 times bigger. So I'm timesing the recipe by 4. That means I need 200 grams of sugar, 50 times 4. I need 600 grams of flour, 150 times 4, and 400 grams of butter. There we go. So how much flour does she need? The question asked how much flour, so that's going to be 600 grams. There we go. Dion has to buy all the butter she needs to make 60 biscuits. She buys the butter in 250 gram packs. How many packs of butter does Dion need to buy? So we know that she needs 400 grams of butter for the 60 biscuits. We already worked that out. So if she buys 1 pack, that's going to be 250 grams and is not going to be enough. If she buys 2 packs, she'll have 500 grams, and therefore that will be enough. It'll be too much, but that's absolutely fine. We can't buy 1 and a bit packs, so 2 would be your answer there. Question number 4. The diagram shows the plan, front elevation and side elevation of a solid shape drawn on a centimetre grid. In the space below, draw a sketch of the solid shape. So the plan is the view from above. So we're saying from the top this looks like a circle, and from the front and the side it looks like a rectangle. And that means that this is a cylinder. Now your sketch does not need to be incredible. It just needs to be a sketch of what that shape looks like. So the examiner knows, okay, yeah, you know that that's a cylinder. And it says we must give the dimensions. So looking from above, we can see that it is 4 centimetres wide. We were told in the question that it's been drawn on centimetre grid. So I therefore know that it is 4 centimetres going across. I can see that from here as well, that it is 4 centimetres wide. Also, to get the height, we can look at either the front or the side elevation, and we can see that that has a height of 5 centimetres. And that is all you need to do. Use a ruler, well, for the straight bits anyway. 2 marks for that one. Okay, question number 6. A shop sells packs of black pens, packs of red pens, and packs of green pens. There are 2 pens in each pack of black pens, and there are 5 pens in each pack of red pens. There are 6 pens in each pack of green pens. The number of packs of black pens to the number of packs of red pens to the number of packs of green pens is 7 to 3 to 4. A total of 212 pens were sold. Work out the number of green pens. Now, normally we'd take this ratio and we'd say, right, I'm going to do 212 and I'm going to share it into that ratio. But this is the ratio for the packets, not the ratio for the pens. So what I need to do is I know that for every pack of black pens that was bought, there are 2 in each pack. So I actually need to take the ratio 7 to 3 to 4. This is the black pens, this is the red pens, this is the green pens. And because the black pens come in packs of 2, if there were 7 packets sold, that would be the same as 14 pens. So I'm going to times that by 2 because there are only 2 pens in the black packets. For red, I know that every time we sell a pack, or buy a pack, whatever it is, then we've got to times that by 5 to get the number of pens. So that would be 15. And then I know that for green, there are 6 pens in each pack. So I'm going to times that by 6, and that would be 24. So that is the ratio for the individual pens. So that's how many pens were sold. Now we're going to do 212 shared into that ratio. Now, if you add up those numbers, 14 add 15 is 29. And 29 add 23, that adds 24, sorry, adds up to 53. And so I'm going to do 212 divided by 53, which fits in 4 times. So I'm then going to times 14 by 4, times 15 by 4, and times 24 by 4, which gives me 56, 60, and 96. And just to check, let's add that together. 56 add 60, add 96 should add up to 112. So 6 add 6 is 12, so 2 carry the 1. 5 add 6, add 9, add 1, that is going to be 21. So there we go, we have 212 pens in total in the correct ratio. Now that on a non-calculator paper might have proved tricky, you might not have just seen that as 4. So don't worry, with ratio you can always just scale it up. So you could have said, well, 14 to 15 to 24, that adds up to 53. Let's double it and go on 28, 30 and 48, and then you could have doubled that again, 56, 60, 96, and that would have added up to 212 that you needed. There we go, so green pens, that's the last section. 96 is your answer there for 4 marks. Question number 8, work out an estimate for the value of the square root of 63.5 times 101.7. Now, normally when we estimate, and this comes up a lot on the non-calculator paper, we round to one significant figure. But this is being square rooted. And because I need to do it in my head, I want to end up with a square number inside that square root. So when I round this, I'm actually going to round it to 64 rather than 60. And yeah, 100 is all good. So 64 is a square number, we can root that, and so is 100. Now, because this is multiplying, you can split it up and you can say that this is the same as the square root of 64 times the square root of 100, so that works. Or you could just carry it through and say that this is 6400, so 6,400, and square root that. Either way, this way you're going to get 8 times 10, so 80, and the square root of this is 80. So either way, my answer would be 80. 2.3 to the power of 6 is 148 correct to 3 significant figures. Find the value of 0.23 to the power of 6 correct to 3 significant figures. Now, to the power of 6 means timesing by itself. So 2.3 times 2.3 times 2.3 times 2.3 times 2.3 times 2.3 is equal to 148, roughly. They've rounded it, but there we go. If I'm making each of those values 0.23, I'm not going to write them all out because I'll be there for ages. But I'm making each of those values 10 times smaller. Overall, I need to divide my answer by 10 to the power of 6 because I'm making it 10 times smaller for each of those multiplications. So overall, it's going to be 1,000,000 times smaller. So I'm going to do 148. And I'm going to divide it by 10 to the power of 6. So that means I'm going to divide by 10, 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 6 times. So I'm going to be left with 0. Now at the minute, look, the 8 is in the ones column. I need to move that 8 columns that way. So it's going to be 0.00000. So the 8, 1, 2, 3, 4, 5, 6. So it's going to go there. 0.000148. So 1, 2, 3, 4, 5, 6. Yeah, we've moved it over 6 times. That would be your answer. Quite a tricky question, that one. Part C, find the value of 5 to the power of minus 2. A really common question, again, for the non-calculator paper. So when we have a power that is negative, we do the reciprocal of that number. So 5 to the power of minus 2 is the same as 1 over 5, that's the reciprocal, squared. 1 squared is 1 and 5 squared is 25. So you're going to square it and you're going to do the reciprocal. 1 over 25, not minus 25. It's the most common incorrect answer I see. We're not making it negative. We're doing the reciprocal. That's what that minus power does. Okay, question number 10. The graphs with equations 3y add 2x is a half and 2y minus 3x equals minus 113 over 12 have been drawn on the grid below. Using the graphs, find estimates of the solutions to the simultaneous equations. Now we know that every single coordinate on this line would make that equation true. And every single coordinate on this line would make the other equation true. So there is one place where the values x and y will make both equations true, and it is that point of intersection there. So let's look really closely. What is that coordinate? So quite tricky. I think that is going to be there because it's between the two values, and I think it's going to be there. So what is the coordinates of that point? It is 2.25 minus 1.3. 2.25 minus 1.3. Simultaneous equations, you're just looking for where the two graphs intersect. Okay, question number 12. Here are three spheres. The volume of sphere Q is 50% more than the volume of P, and the volume of sphere R is 50% more than the volume of sphere Q. Find the volume of sphere P as a fraction of the volume of sphere R. Now this is really hard because they've not given you any values. So what you could do in an exam is say, okay, I'm going to make this 100 centimeters cubed. You might just find it easy to give it a value and then you can work with it. We're giving our final answer as a fraction. It doesn't really matter because we can cancel down the fraction what number we pick to begin with. So let's say the volume of sphere Q is 50% more. Well, we know if we made that 50% bigger, that would be 150 centimeters cubed. And then if I made that 50% bigger, I would get the value of R. So 50% of that would be 75. Add it on is 225 centimeters cubed. So there we go. Find the volume of sphere P as a fraction of sphere R. So that would be 100 out of 225. Both of those are divisible by 25. So I'm going to make that 4 over 9. That would be my answer. So that's one way of doing it. There are lots of different ways of doing it. You could have picked completely different numbers, but that's the way that makes the most sense to me. So hopefully that makes sense to you as well. 4 over 9 would be your answer. Okay, question number 14. Find the exact value of tan 30 times sine 60. Give your answer in its simplest form. So I've been doing this with my year 11s this week. What we do for exact values, what I do, there are lots of different ways to remember them. I personally remember the two triangles, 1, 1, root 2, 45 and 45. We don't actually need that one for this question. And I remember this triangle, 1, 2, root 3, 60 and 30. And if you can remember those two, then you can pretty much work out any of the exact values. So remember you've got SO, Ca, and TOA. This is a non-calculator paper, this is why we're having to do this. So if I want tan 30, I want to imagine I'm here. We know that tan 30 is the opposite over the adjacent, which is root 3. So tan 30 is 1 over root 3. You can also rationalise that and say it's root 3 over 3. Either way, both of those are correct. Okay, sine 60, imagine you're stood here. Sine, using SO, is the opposite over the hypotenuse, root 3 over 2. So sine 60 is root 3 over 2. Now I'm actually going to use this one because I'm thinking then they're just going to cancel. So 1 over root 3 times root 3 over 2. 1 times root 3 is just root 3, and 2 times root 3 is 2 root 3. We're then just going to divide by the root 3. You could have cross-cancelled to begin with, and you're left with a half. And that is your answer. Whenever you get an exact value question, I always say, just guess a half if you don't know. And in that case, it actually was, and that was 2 marks. Okay, question number 16. There are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4, 5. The 3-digit number 553 is one way that the dials can be set, as shown in the diagram. Work out the number of different 3-digit numbers that can be set for the combination lock. So we can have repeats. So there are 5 different possibilities for the first digit, 5 different possibilities for the second digit, and 5 for the third digit. So if we want to know how many combinations that is, I would multiply those options together. 5 times 5 times 5 is 125. That's how many different combinations you've got. How many of the possible 3-digit numbers have 3 different digits. So we've still got 5 possibilities in the first spot. But whatever we choose to use here, let's say we use a 4, then we cannot use that in the next position. So there's only 4 numbers then left to use in the second position. And similarly, whatever 2 numbers we've used, we've only got 3 numbers left to pick from in the third position. So if you want them all to have different digits, you've got 4 to choose from after you've selected the first one, and then 3 to choose from after you've selected that one. 5 times 4 is 20, times that by 3 is 60. So that's your answer for part B. Question number 18. Express root 3 add root 12 in the form a root 3, where a is an integer. Now for this we need to think about all our square numbers, 1, 4, 9, 16, 25, 36 and so on. If you get a surd that has a square number factor, so these are my square numbers, then we can simplify it. And I'm looking at root 12 and I'm thinking, okay, well 4 goes into 12 as a factor. So I'm going to change this. I'm going to leave the root 3 as it is because I can't do anything with that one. But I'm going to change root 12 to be root 4 times root 3. Because 4 is a square number, it's one of these, it's the biggest square number that goes in, and then we need to use 3 with it because 4 times 3 is what makes 12. Now the reason you have picked root 4 is because root 4 becomes 2. That is the square root of 4. So this becomes root 3, which is 1 root 3, although we don't need to write the 1, add 2 root 3, and now that they're both root 3's, we can add them together. So that is going to be 3 root 3. For part B, express 1 over root 3 to the power of 7 in the form root b over c. So what have we got here? 1 over root 3 times 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 1 over root 3, that's not 3, times 1 over root 3 and one more times 1 over root 3. Now that might seem really difficult, but actually every time you multiply this by itself, you get 1 over 3. Root 3 times root 3 is root 9, which is just 3. And we know that when we times fractions together, it's the top times the top and the bottom times the bottom. Okay, so those two make 1 over 3. These two make 1 over 3. And these two make 1 over 3. So I've got that times that, and then we've just got this guy left on its own. So that would be 1 over 27 root 3. Now the problem is they want the surd on the top, and we can never leave a surd on the bottom of a fraction. The only way to get rid of a surd is to times it by itself, and that's called rationalising. So I'm going to take my 1 over 27 root 3, I'm going to times the top by root 3, and I'm going to times the bottom by root 3. And we can do that because that would just give us an equivalent fraction. We know it's an equivalent fraction because we've times the top and the bottom by the same number. So that becomes root 3 over 27 times 3 from this. And that's 81. So root 3 over 81 is your answer. There we go. Question number 20. H is inversely proportional to P. So H is inversely proportional to P. That means we use the fraction. We can't solve equations with fish in them. So H equals K over P. So remember, you always change that proportionality symbol to be an equals and a K. And then we've also got P is directly proportional to root T. So we don't use the fraction if it's directly proportional. We only use that for inverse. And so P equals K root T. Given that H is 10 and T is 144 when P is 6, find a formula for H in terms of T. So we've got to sort out both of these. So I know that when H is 10, P is 6. So therefore, if I times both sides by 6, I work out that K is 60. So therefore, I know that H is 60 over P. That's my formula for H. I'm now going to do a similar thing for this one. I know that P is 6 when T is 144, so K times root 144, which means that K times 12. I want to work out what K is, so I'm going to divide both sides by 12. So you can use 0.5 or a half. I'm just going to use 0.5 is K. Always go back to that second thing you wrote, and we're now going to say that P equals 0.5 root T. So I've got my two different formula. Now for this question, it asked me to find a formula for H in terms of t. So I've got a formula for h in terms of p, and I've got a formula for p in terms of t. So what I'm going to do is I'm going to change this p to be this, because I know that that's what p equals. So I'm going to write h equals 60 over 0.5t, root t, sorry. But you can't leave a decimal in your fraction, so let's times the top and the bottom of that fraction by 2, just to make it so it's only integers, and that would be that. So there we go, your final answer is h equals 120 over root t. Question number 22. There are only R red counters and G green counters in a bag. A counter is taken at random from the bag. The probability the counter is green is 3 over 7. The counter is put back in the bag. 2 more red counters and 3 more green counters are put in the bag. A counter is taken at random from the bag. The probability that the counter is green is 6/13. Find the number of red counters and the number of green counters that were in the bag originally. Okay, so this is feeling like a tree diagram. There's only red and green in the bag. The first pick is going to be 3x over 7x, okay? I don't know how many counters are in the bag. I know this is the probability, but that could have been 6 counters out of 14. It could have been 9 counters out of 21. We know that the fraction is correct, but we don't know what it's been simplified down from. So I'm going to call it 3x over 7x. And therefore, the probability of red would be 4x over 7x. Now, we're taking a counter and we're putting it back in. But then 2 more red and 3 more green are put in the bag. So on our next pick, we've actually got green and red again, green and red again. But we know that we've got 5 more counters overall. So 7x add 5 is now the total number of counters. 3 more green, so that would be 3x add 3 to the number of green. And 2 more red. So red is going to be 4x add 2 over 7x add 5. Now, we could do all of these branches, but the only branches I'm really interested in here is the probability that the counter is green is this one. So I want this to equal 6/13. Okay, I don't really need to fill anything else out. I just need to know that that is 6/13. So there we go. I'm going to write 3x add 3 over 7x add 5 equals 6 over 13. Now, when you have an equation with fractions on both sides, we can just multiply the denominators up like this. So 13 lots of 3x add 3 equals 6 lots of 7x add 5. Expanding that out, 39x add 39 is 42x add 30. I'm going to take 39x away from both sides. And I'm going to take 30 away from both sides. That leaves me with 9 is 3x. Dividing by 3, I get x is 3. So that means that in the bag originally, because I know that it was 7x, I need to do 7 times 3. So there were 21 counters in the bag originally. Really tricky, that one. Oh, we've got to do red and green separately, have we? Okay, so green was 3 lots of 3, so that would be 9. And red would be 4 lots of 3, so that would be 12, and that does indeed add to make 21. There we go, 5 marks. Very, very tricky last question. If you found that difficult and you want another one to practice, Google Hannah's sweets question. There was one that came up a few years back and it went viral because people said it was the impossible question, but it was really similar to that one. So Hannah's sweets, if you Google that, you should find that question as well, and that would be a really similar one to practice. But yeah, probability from a tree diagram with algebra is really tricky, very much grade 9 at the end there, so well done if you did get that. I hope you found the video helpful. If you've got any questions, please let me know in the comments. I'd be happy to help you. Hope you have a lovely week, and I will see you guys next week.